Hi, and welcome back to Algebra 1. Our goal for today is to continue working with our relations, and more specifically, if we can identify a relation as a special type called a function, and if we can identify the domain and range of both discrete sets of numbers or continuous graphs. So, reminders from our previous lesson, a function is a rule that establishes a relationship between two quantities, or more specifically, a relationship that for each input it is associated with exactly one output. So each domain value has exactly one range value, or each input has exactly one output, or for each x value of an ordered pair, it can only go with one corresponding y value. So our goal for today is to expand on what we added in our last lesson with our mapping diagram test and our vertical line test that helps us to establish if a relation is a special type called a function. To can we describe the specific values in the domain and range of a relation or a function, no matter which one we're given? So we're going to start with discrete values. They're a little bit simpler to work with. So if I'm given a table or ordered pairs or a graph with individual points, can I identify the collection called the domain? And can I identify the set of numbers that would be the collection called the range? Remember, your domain or your input values are your x values, and your output range are your y values. You have to remember that, and especially once we go to our continuous graphs. So domain values here, the hardest part we're with these discrete values where it's individual points is we're making a list of a set of numbers. And the way that we do that is with curly brackets. So we're going to start here with a curly bracket. And our domain is our x's. So you need to remember ordered pairs go x comma y. So all our first values in our ordered pairs represent our collection called our domain. So we want to go in numerical order here. This one's nice because it's in that order. So 0, 2, 3, and 5. Or what we would have put into our input part of our mapping diagram is really our domain. All right, close your curly bracket. So the domain for this one is the set of numbers 0, 2, 3, 5. All right, the range is your y values or what's second in your ordered pairs. So when we look through here, a 1, a 4, a 7, and a 4, I don't need to repeat numbers. I'm just listing anything that lands in the range. So 1 is part of the range, 4 is part of the range, and 7. And then I need to finish my curly bracket. All right, and we should have something that looks like this. 0, 2, 3, and 5 for our domain, and 1, 4, and 7 for our range. Again, when we're working with discrete values, which are individual ordered pairs, identifying the domain and range are pretty simple. So let's look at another one. The only thing that's different here is we're given a table of values. So I've added in the x and the y here just to remind you that a table will always go in the order of an ordered pair. So when it's horizontal like this, the top will always be your x and your bottom will be your y, even if these aren't listed there for you, right? Your table matches the order of your ordered pair. So whatever's first in the table will always represent your domain because it's your x's, and what's second would always represent your range. All right, again, this one's pretty simple because our table is put in order for us. So 1, 2, 3, 4, and 5 are our domain values of this particular function. And our range or our output values are 23, 36, 47, 61, and 73, right? Those are all the possible range values for this particular function, which we can tell that this one's a function because for each domain value, there's only one range, right? There's nothing relisted up here. So it is a special type called a function. And so when we're done, we should have a 1, 2, 3, 4, and 5 describing our domain, and 23, 36, 47, 61, and 73 would be the values that would describe our range. All right, let's look at one more discrete or individual point version, which is a simpler, and then we're going to look at our continuous graphs, which is much more challenging. All right, so for this one, our domain is any possible x. So the first thing I would maybe want to do is write out my ordered pairs here. So for this first point, we're at negative 9, comma 7. For the second point, we're at negative 6, comma 7. For this one, we're at negative 2, comma 7. For this next one over, we're at 2, comma 7. And then 4, comma 4 is that next one down. Oop, 5. My fault. Couldn't see my own numbers over here. We're on the 5. All right, 4, comma 5. Oh, gosh. Boop. All right, 4, comma 5. Then 6, comma 5. And 9, comma 5. All right, so let's start with our domain, which is any possible x. All right, so starting as small as possible was at negative 9. Then our negative 6. Then our negative 2. Then 2, then 4, then 6, then 9. Close that curly bracket. All right, our range is a little bit simpler because all 3 of these are the same y. Oop, all 4 of these, and all 3 of these are the same y. So really our range just has 2 things, positive 7 and, oop, let me rearrange this. Numerical order, my fault, positive 5 and positive 7. Go ahead and close your curly brackets. All right, so we've looked at the simpler of the 2 types of identifying domain range, which is with discrete points. I'm given individual ordered pairs, and I pull out my x's and y's. I'm given a table, and I can pull out my x's and my y's. Or I'm given individual points in a picture, and I can pull out my x and y's from it. The harder part with domain and range is when we're given a continuous graph, meaning there's no stop to it, right? Like a line is a continuous graph. When that's the case, our domain and ranges get described as inequalities, right? Where do they start and where do they end? And sometimes those are compound and inequalities. So for example, for this first graph, and maybe it would be helpful here if I go in and highlight it, right? It starts here, and it goes up here to there, it goes to there, it goes up there, it goes over there, and it goes to there, right? That's the graph. That's what we're looking at. So remember, your domain is all possible x's. So for me, I think how far left to how far right, right? That's your domain. So if I start here, I'm at negative 3, right? Domain is your x. So I'm looking at numbers here on my x-axis. So I'm starting here at negative 3, and then it's continuous, yep, until we get here, which is at 5. So x is everything in between here. So the way that we would show that is it starts at negative 3, and it goes to 5, and x is in between it. And since these 2 ends are closed in, it could be equal to those. So negative 3 is less than or equal to x, which is less than or equal to 5 is how we would describe it. Where x is everything in between and including the negative 3 and 5. All right, so a little bit of a trip back to our review here of our interval notation. So remember, for interval notation, when you have equals to, you have a bracket. So it could be equal to negative 3. So we're going to have a bracket, starts at negative 3, goes to 5. And then it could be equal to 5 again. So we're going to have a bracket here. All right, we want to do the same thing, but now for our y's. So I think bottom to top, right? That's our y. So we're looking at numbers now on our y-axis. All right, so on our y, this is the beginning of our graph, right here at 0. And this guy up here is our top, up here at 3. So y can be anything in between those. And again, since these are closed in at 0 and 3, it could be equal. So it starts at 0, goes up to 3, and it could be equal to. And the way we would show that is 0 is less than or equal to y, which is less than or equal to 3. So our interval, again, we should have brackets because it could be equal to our 0 and our 3. So our y values start at 0 and go all the way up to 3. And so it would look something like this. So, all right, let's try another. I know these are kind of tricky. All right, I'll highlight the graph again. It starts here. So maybe we do our x. Left to right here gets us our x's. So that guy is right here at -3. And then it goes down all the way here, all the way up to here. So to +3. So our x can be anything in between there from -3 to 3. X is in between there. Since both of these are closed in circles, it could be equal to those values. So x is in between -3 and 3. And since it's equal, brackets here on our interval, not parentheses. All right, now let's do the same thing for our our range, which is bottom to top, right? Work from the bottom up. All right, bottom to top. All right, so here's the bottom of our graph right down here. And it's a solid line there. So at this -3, it could be equal to that. So -3, we're looking for y's here. And then up here is the top of our graph at 5. So y is everything in between -3 and 5. And since everything is closed in or solid at those locations, it could be equal to. So -3 to 5 in brackets, not parentheses. All right, let's try another. All right, here's our sort of lowest spot of our graph. Here's sort of a spot of our graph. Here's a spot of our graph, right? That's what we're looking at. That's what we're trying to describe. Right there, all right? All right, so x, from left to right, we're trying to describe. So here's the farthest left. It's at 0 on our x-axis. And then our farthest right is not this guy, it's this one, right? That one goes further. So it's at 4. So x is everything in between there. So from 0 to 4 is our x values. And since this is closed and this is closed, it could be equal to. So from 0 to 4. All right, let's go from bottom up, right? Bottom up. That's our y's. From bottom up. All right, so this is our bottom. This is our top. So we're going over here to our y-axis here. We're going from -4 to 4. So our y values are in between -4 and 4. And again, everything's closed in, so it could be equal to, there's no like dotted lines or open circles here. All right, so we start at -4 and we go to +4. All right, number 4. All right, here's our graph. It starts there. It curls sort of up here like so and ends there. All right. And it hits our y-axis over here. Okay. All right, so left to right gives us our x domain values. So as far left is over here, which is at 0 on our x-axis. The farthest right is here, which is at 4. So our x value is between 0 and 4. Again, everything's filled in. There's no open circles or dashed lines or anything. So these could be equal to, which means our interval is from 0 to 4. All right, our y's, bottom to top, bottom to top. All right, that's our y. All right, so our bottom down here is at 4. Our top up here is at -4. And our top's at 1. So our y values can be between -4 and +1. Again, it's all filled in and solid, so it could be equal to. So from -4 to +1. All right, number 5, we have an open circle here. And then our graph goes like down, like so, and then up to here. All right. Let's try to go here. Left to right is our x values called the domain. So this is our farthest left. It's at -5. This is our farthest right. It's at +1. So x can be everything between -5, right? For this domain, we need to be getting numbers off this x-axis, and +1. Now, here's where you need to be careful. At -5, this circle is open, so there's no equal to there. It's just less than. And then at 1, it's closed in, so it could be equal to. So our interval notation is a little bit different here too, because at -5, we should have a parenthesis, not a bracket. And at 1, we should have a bracket, right? Because this one's open, that one's closed. All right, let's do bottom to top. That's our y, is called our range. All right, our lowest spot is right here at -4. All right, we're trying to get our range. We need things from this y-axis. So our highest is at 3. At this bottom, it's a solid line, and at this top, it's a solid circle. So everything's included there. -4, less than or equal to y, which is less than or equal to 3. Brackets now on both sides, -4 and 3. Okay, let's try one more. All right, this one is completely different. Notice there's arrows on the end here, which says it's going to continue getting a bit taller and a little wider as it goes, right? It's going to keep getting a little bit wider, a little bit wider, a little bit wider, a little bit lower, a little bit wider, a little bit wider, and so on. So it's growing wider and taller as it goes, which means there's going to be no end up or down and no end left or right. So if I said I want to go left to right here, I would say, well, there's no end. This is going to go on forever to the left. This is going to go on forever to the right. So I can't really write that as an inequality because it's really like an all real solution scenario. Since it's all real solutions here, right? All possible numbers, all real numbers are possibilities for our x's. That's what we'd have to write here. All real solutions. Which means our interval would go from -infinity to infinity. Now, you need to remember with infinities, we can never actually get there, so we always have to use parentheses. Now, same thing for bottom to top. This goes on and on and on forever. It starts as low as -infinity, goes all the way up to +infinity. So again, this would be all real solutions here. And so it would go from -infinity to infinity. All right, I hope that helps you attack your work for today. See you guys later.